Let's see. Still testing our broadcast. And it's almost live. I think we might actually be live now and out there.
Okay.
We'll know in just a second. Maybe not. Maybe we're just going to wait for the broadcast to be published.
It's exciting that we might actually be on time for one of these. That's quite nice.
That would be crazy. Crazy. Oh, there we go. I see it's just kicked us on. All right. We are good to go. So I'm going to kick it over to two-person mode. Crazy. Oh, there we go. Welcome, Jason, and just get a quick idea of our mic levels. So I'm going to
Yeah, if someone could give us let us know if our mics sound okay, because we tend to have a lot of trouble getting the microphone to synchronize at roughly the same level. So if we need to nudge it, let us know now before we start. Let us know if our mics sound okay, because we tend to have a lot of trouble getting the microphone mild echo.
Sounds like it's okay. I don't know. That mild echo was me. Sorry. That was me checking the volumes too. But it sounds like we are just about equal, which is okay. Good stuff. Anyway, welcome everybody. Oh, we'll switch to the chat mode so we can hopefully see chat show up again.
Just a heads up for everybody. Apparently there is a bit of an echo, and I'm also quiet, which is not a good sign.
Oh, do you want to turn up just a little? The echo was me.
How about that? Do I sound okay now? Good.
Okay, cool. Yeah, the echo was just I turned my speakers up so I could hear, and I was listening to us. So I guess the mic didn't do all of the magic that we were hoping for. Anyway, good. Welcome everyone. We're gonna get started, and we're just gonna dive into solid principles in just a minute. But first, I wanted to just talk real quickly about a couple things. First, I guess I wanted to say thanks to Jason and welcome to Jason. It's awesome having you on here all these times, and you still need to start a channel. I'm still waiting.
We're getting there.
Still waiting for your YouTube channel to come, but yeah, anytime now. That'll be nice. So let's see, what else did I want to talk about? The conference stuff. So anybody that's on my email list has probably already seen it already, but I sent out an email about putting together an online game dev conference. Just something where we can get together, have some talks, learn some interesting things, and have some fun with it. I have a friend who does a lot of these online talks for non-game dev stuff. And since a bunch of things keep getting canceled and all the meetups in my area aren't happening and all the flu stuff, it's kind of messing with stuff, I figured why not just try to throw something together and have some fun and just, put together a quick conference where we can all learn stuff. So I sent out a survey to see what kind of topics were interesting. And the whole reason I wanted to talk about this part was because I thought that the results were kind of interesting. And we're going to dive into the solid stuff right after I go over these results. But I just wanted to share what I'd seen so far. I also wanted to share the link. So here, let me copy that link and drop it into chat. So if you're interested and you want to put in your own opinion on this, as soon as I figure out how to add something into chat by pasting.
By the way, for anybody asking what is solid, don't worry, we're going to get right into that for a very long time.
Yes, we're going to dive into solid for a long time. There's a lot to talk about there. There are 5 very important principles. But first, let's switch over to desktop mode. So I sent out the, let me go to the question mode first. I want to show it before I spoil the results. So I sent out this form right here. And Jason, I think you've seen this one, right?
It was. I haven't. No, I'm actually filling it out as we speak.
Oh, okay, cool. So everybody in chat can see it too if you want to go through and just fill out the results. And I think fill it out. I think you'll see the results after. But essentially, it's trying to get an idea of what topics people would be interested in. I had an idea of what I thought people would be interested in, and it didn't match at all with what the results were.
You have me excited. I'm looking forward to pressing the button and finding out myself.
I thought it was really interesting. Did you hit it already?
No, we're getting there. 1 second.
Let me know once you've finished filling it out, and then we'll switch over. It's going to be interesting.
Okay.
All right, you done?
Speak previous, loading. Here we go. Yeah.
So, yeah, we go to the results and the summary. So, the number one most requested or number one thing for very, very wanted was game design. out of all of the topics, game design was at the top, followed by AI. People are filling it out, so it's just bouncing over. But you can see AI.
Yeah, well,
Actually,
AI has a good spike. I think it's actually on top now,
it
isn't
might.
it?
Yeah, it
Yeah.
looks like it might have
Yeah.
gotten to the top. Oh, it did. Yeah. So AI is now top, followed by game design. And as people are filling it out, I don't know if it's gonna let me slide through this, but I'd say just if you haven't had a chance to fill it out, go fill it out and check out the results. But solid principles were actually pretty high up there too. I don't know if you've seen when I flip over here, you can kind of see it. They actually got a really high rating and a really high on the green bar, which was like the number one thing, which was nice to see too, and kind of a surprise.
Yeah.
So
I will say solid principles is actually my favorite topic of all of these. I've said it before, interfaces is my favorite is one of my favorite discussions as a programming concept, but solid principles is probably right up there as number 2 because I think they're the most valuable. They're one of those sort of really deceptively these are the things which will fundamentally change the way you program. Like you can learn AI, you can learn networking, and they're very useful, but that's just learning how to use another tool. If you really understand how interfaces work and how solid principles work, you won't be working the same way. You fundamentally won't write code the same, and that's why they really fascinate me as topics.
I'd say I completely agree there. Like, it's a huge. I mean, and that's I guess kind of why we're starting with this talk. And speaking of that, do you want to? I guess we could just start diving into solid principles and maybe start with interface segregation or I don't know something else. Maybe open closed principle, something
You're
where
gonna
we
go
can
out of
kind of
order.
dive into
I thought we'd
interfaces.
just go in proper order from the S onwards.
Oh, you just want to go in word order instead of
Why not? Just rather than confusing people. I mean, it's up to you. I don't mind
Oh,
either
I
way.
don't care. Yeah, we can go in order. In fact, I pulled up this quick little page that's got all of them in order with I think their official definition and then
Hmm.
some examples that are okay examples, but they're not really Unity specific examples. I figured we could maybe talk about them and then
Hmm.
dive into like a more game relatable example instead of a shape example like
Yeah,
we
yeah.
normally
I
get.
do find that's probably the biggest thing missing is they lack a lot of context. They're kind of like design patterns in general. If you try to learn them, you end up finding, hang on a second, I may vaguely understand it, but it doesn't really apply to anything I'm doing. So I think we kind of owe everybody a good example of a practical implementation of some of these.
Yeah, I think you are dead on with that. Yeah, like circles and squares and shapes, like they're very easy to do examples with because they're things that everybody understands, but they don't, or they almost never apply. I don't know many people that have to go about dealing with circle and shape code constantly. Like, so yeah, let's dive into single responsibility principle, the first one, which
All right. Well,
just
I think just before we go letter by letter, let's start with what they are, because I think some people aren't even familiar with the term, right?
oh, that's a great idea.
So the acronym is the solid principles, and without going into too much details about the origin, um, basically Bob Martin and friends, some of the OG programmers who came up with a lot of this stuff, uh, was sort of looking at the general problems that tend to affect software. And in a kind of high level way, most of these things are designed to make software more maintainable. Because what happens is you could write code and it works perfectly fine, but the problem becomes the biggest most common concept in software is change. Every system you write will fundamentally have some additional feature at some point. You'll change something, you'll add something, and there's a cost associated with that change. You have to rewrite the old stuff and add the new stuff in. And in bigger systems, the more change you have, the more cost. And this is not just for time, but also in money if it's a big company. So the solid principles are a way of writing code that is more maintainable by being more open to change. So you support the ability to change your code without kind of significant costs and regressions and that kind of thing. And they basically came up with a bunch of kind of individual ideas or rules that you can apply to your code. And if you maintain them, you'll find your code is just easier to work with. It's just in general easier to maintain, easier to write, and overall easier to extend. And we'll go into each letter one by one and explain why. But yeah, so that's the general idea, right? If you work with these kind of principles, you sort of lean towards a topic called clean code. and it's just sort of writing code that is maintainable and easy to extend. And hopefully we'll demonstrate why that's a very important thing.
Yeah. And when you say easier, it's not just like anybody that's listening thinking like, oh, it's going to be a little bit easier. It's dramatically easier. Like you're going to make things 5 to 10 times easier to change and work with. Make it so that you can work a lot faster and just keep making constant changes, updates, and patches without breaking stuff. So it's a very, very big, dramatic shift. And I think following the solid principles is kind of how you avoid, or at least a good way to help avoid those situations where your game designers have requests and you just have to say no, where they're like, we can't do that. Like, it's not feasible. We would have to change too many things in the game, or everything would break, or it's going to take a year and a half to change instead of a week like it should. So I mean, it's big when you make this jump. It's not like a tiny jump. It's a huge change, I think. All right, so yeah, shall we dive off with the S in solid? The S, which also has 3 more, which turns into SRP to make it even more confusing.
Yeah, exactly. So you can
go ahead.
Sorry, go on. No, I was just gonna say that you're right. Like, so the solid is an acronym for a bunch of rules, and each rule tends to often get acronymed as well. So the the S also can be SRP, which is single responsibility principle.
But that's all just the S.
Yeah. So do you want to give a brief summary of that before?
Let me just read off the definition first, and then we'll go from there, because one of the definitions is great. So I want to read them off just so we can get to the funny one. A class should have one and only one reason to change, meaning that a class should only have one job. Yeah. So, I will just talk in their example. Well, I don't know. Should we dive into their example, or do you want to just?
Well, let me start with one thing, because I find there's often two camps of people, right? There's people who have never heard of this idea, and we're we can sort of go through why you use it. But I think more importantly is to tackle the other end, where people have heard of this and they end up thinking it leads to bad code because it leads to class explosion. So let me cover both sides, right? So the single responsibility sort of states that the goal of a piece of software is to do a job. And so you don't want to write code that will change for multiple reasons. Now, here's where people make a mistake. A lot of people misread the single responsibility principle as saying code should be doing one thing at a time. And that is a very subtle but wrong interpretation of what that means. So let me see if I can give a good example. If you were building a health system does multiple things. So if you have a health bar has a visual part that draws. It has some logic to decide whether something can go in or out of kind of the limits of what that value is. And it also has the data itself. Now, you can draw your lines about what that responsibility is multiple ways. And as I go, will you zoom in a little bit there, Jason? Apparently, it's a bit small on the screen.
Yeah, let me do that.
So a common sort of naive implementation of this is people say, well, what we can do is we can split each and every portion of those out into individual responsibilities. But I think a better way to describe it is Uncle Bob, who literally made this kind of rule, among others, highlights it differently. So rather than saying your code has individual responsibilities, so for example, if you did something that clicks to place towers in a tower defense game, people might think, oh, well, one responsibility would be the input, one responsibility is the raycast, one responsibility is the character, one responsibility would be sort of adhering to the surface and this kind of thing. You end up getting to this really weird scenario where you can technically take any piece of code and drill down each responsibility down infinitely. And so you can get to this weird scenario where you keep telling yourself that, oh, well, I can't put these two things in a class because they're two separate responsibilities, and you keep going down. That is why people often make the mistake with this, that they kind of approach it wrong. So let me give a better approach. If you're trying to apply the single responsibility to your code, keep in mind most of these rules are designed for enterprise solutions. So they're not just you by yourself writing code for yourself. So a lot of the rules are not meant as a guideline for how you should individually, on a personal level, isolate your classes. A lot of these rules are designed around how do you build scalable, large applications. And so if you keep that in mind, you realize the single responsibility principle is more talking about systems and not individual classes. Now, it is about class files, but we'll get to that in a second. What I'm getting at is um, there are often different departments in a company. So in a large company, you have the UI department or UX, whoever's doing the designing. You've got people who manage databases and the backend systems. You've got people who manage what the business rules are for the application. And so each one of these people have a different job. And we can go into the details about CTOs, CFOs, and DBAs and all the different actual titles. But all I'm getting at is when Uncle Bob says single responsibility, he's saying one reason to change, aka one person's will ask you to change this. So, for example, if I am the UI designer for our application, I might come back and say, I want this health bar to be an actual bar that goes back and forth. And then I might say, you know what, I'm changing my mind. I want it to be a number that goes up and down. I said, no, I'm changing my mind again. I want it to be a disc, a radial thing that goes back and forth. These are all multiple reasons to change your system, but they come from one place. They come from the UI department. They come from one location of the application. And theoretically, changes to the way the UI represents should have no bearing on things like business rules. What is the minimum health? What is the maximum health? So the responsibility boundaries lie in who's asking you for those changes. So effectively, if the guy who's in charge of managing where all the data is stored says, I am changing our backend system, so we're no longer using text files, we are now using MySQL, and they change that, you have to change the code accordingly. And where do you do it? Well, you want to change it in one place. So this is an elaborate way of saying the boundaries of your application don't lie in this minuscule sort of, I'll make a value provider and then a float provider and then a provider, and you end up writing this insane chain of single responsibilities that are nested. That's how you fall into really bad code reuse issues. It's very simply, what is a reason someone might ask the system to change? I am building a banking application. It might change because the rules about what happens to the money changes, where the money goes might change, and how the UI might look might change. So there are different kind of reasons a system could change. And if you isolate each one of these into single layers and you stack the application together, you end up making your life easier. So try to figure out in any system you design, if you're doing like an enemy spawner, the rules over when enemies should spawn is one thing, what enemies are spawning is another, and where they are spawned is another. These are single responsibilities. And so what you might do is you might build a spawner that has different responsibilities and you stack them together. So
right.
It's a hard thing to do, but it's trying to figure out where those lines are effectively.
Yeah. That sounds good. I mean, and you're talking about I think a very common problem where people over separate things and separate down what should be methods into their own classes just because they go a little overboard and then end up often writing more code instead of less because they're writing too many layers of abstraction so that they can have like this one tiny little file, right? But then there's a dozen other files that are all doing stuff. I think it's important to note too, when you're talking in games, it's very rare that you end up with a lot of different people or different departments needing things, but you do end up with different gameplay systems, and sometimes it's the same. It may be different designers, but a lot of the time it's like the same designer, just switching in the context of different systems that they're responsible for. So it may not always be a different person or department, but it could just be a different logical subset of your project too, right? Like kind of like on your enemies and your spawners. Like your spawner code should know absolutely nothing about how combat works or have any references to anything combat related or any of that kind of stuff. It should only know about spawning.
And see, and you've touched on exactly where I wanted to get to, and what I think a common misconception is. You'll get people who come from a kind of businessy background who will look at the single responsibility principle and they will apply it incorrectly to game. Because when I talked about those layers, like I said, I was applying them to different jobs. And I think that's a more valuable way to approach it. And like Jason was saying, in games, those jobs don't usually exist in the same way. Instead, in a game, you tend to have the gameplay designer, you have the person who's doing the level design, the person who's doing the UI design, and so your boundaries might be different. So a common mistake is that people will apply the single responsibility principle in the same way in a game that they would in a event-driven desktop application where different layers are handled by different jobs. So as Jason was pointing out, this is why I really focused on it being job-based, because in a game, it is somebody's job to deal with what the spawning rules might be. And it might be someone else's job to build the plug-in system for the gun, and someone else's job might be designing the front screen or the menu. And so that's how you design for single responsibility. You decide whose job will it be, and if they ask for changes because they're adding a new feature to this spawn system, and I need to forward it up onto the UI, how many pieces will that touch, and who will? If someone gives me that change, how much of that knock-on effect will that have? So that helps you to figure out where those lines are. You draw the lines for each responsibility based on who will ask me for this, or whether it'll affect other parts of the system. And you group like things together by who will ask you for those changes. Is the game designer going to ask them for it, or is the UI designer or the level designer, or so on?
Yeah. Yep, that makes sense to me. I wanted to pull up an example real quick of something somewhat similar. I guess it's a smaller real world example, and just kind of run it by you. Just see how well it fits into this. So I've got I think one of the things I showed you. Sorry, I'm switching screens around. Oh, also I wanted to address the super chat real quick. Thanks for that. Yes, we'll definitely do another video on that soon. I've done one video. So the question was about can we make a video on good coding practices like variable names and standard code setups. I assume
I've had a lot of people ask about the underscore, and I think you should really point that out to people. You should do a little video explaining why you choose certain naming conventions and things, because I don't think that's ever really been covered.
Yeah, I think I'll do that soon. Just do one on naming conventions and standards that I've seen in projects, and then kind of the ones that I like to use now. I've gone through. I mean, I assume for you they change constantly. They do. They have for me, and I can share out kind of where we're at now and where I've gone through, and some of the places that I found really interesting, just tips on ways to lay stuff out and standards to use. So yeah, I'll do that. But let's jump into this code. So remember before I showed you the ability refreshing thing?
Mm-hmm.
So like it was essentially like a cooldown system, right? So there are a bunch of different ways that an ability button can go on cooldown, right?
Yeah.
It could go or sorry, not on cooldown. I'm saying cooldown. Because cooldown's here, but it could be on cooldown. It could be stopped because you're stunned, or because you're out of range, or you don't have enough mana to cast the spell, or whatever, right? So there are a bunch of reasons that the indicator could show as like not available, right? So there are a bunch of these different classes for it, and the way that I have this set up is with a separate class.
By the way, you might have to zoom in a little bit. I'm having a hard time reading this.
Oh, okay, yeah. I hadn't gotten into the code is why. So, but there are a bunch of different classes for different ways that the interface could not be available, right? Like if they're stunned or charmed or whatever it is, the things that would prevent them from using a spell, right? Or they could also be on cooldown. And then when it comes to this was something. The reason I want to bring it up is because while I was working on this, I was thinking a bit about the single responsibility principle and thinking, okay, now this cooldown one, it used to be really simple. It would just do like basically like a faded graphic or a filled graphic that would cover, right? And it would count down and just reveal the thing. Now it's doing a little bit more. It's showing a countdown text. It's flashing it's flashing when it's done, and doing a couple other little things that are all visual. But they're all exactly related to being on cooldown, being blocked because they're on cooldown, and they're all related to like this one indicator. And for a moment, I kind of struggled. I was like, hey, like this almost feels like I should split this into another class, but it's still it's still going to change. I guess what it came down to for me was that it's still going to change for the same reasons, right? Because we've changed the way that cooldown works. So I left it in the same file, and it ended up being a bit longer than a normal file, but it also hasn't been cut down and optimized, right? Like I think that this is gonna shrink down to like 80 lines once I've got all this kind of crap out of here. We've got commented stuff and checks and kind of debugging stuff in here, but I guess it was just kind of it was my own struggle with that. Should I split it down? Should I split it down? Should I split it down? But just realizing that I think at least at this point it's all kind of on the same level and it's good. Would you split it down more? I'm curious.
Well, I tend to use a particular pattern for UI stuff. I don't know if this is derailing, but I use a humble dialogue pattern for this kind of thing because it's very delineated between presentation and logic. So I would split it, but I would split it almost directly in half. But I think you're right insofar as it's still all cooldown related. So I wouldn't move it into anything as complicated as a bunch of different separate things. I wouldn't go full MVC or anything crazy like that. But what I like to do is I like to build a presentation interface where I would say cooldown presenter, and I would put the Text Mesh Pro and the materials stuff into it, and I would expose a contract which has a settable boolean. Actually, let me see if I can give an example of this without. Uh, hmm. I don't suppose you have a notepad there. I can just quickly give an example that might explain it better than me trying to come off the top of my head. Just like if you can just pull up an empty file, and I'll just if I can describe an interface, it would probably make it easier than me trying to describe it.
We can do that. We can just do a new code file.
Sure, let's do that.
Let's do that. Let's see. Apparently I can't just do it in there. I forgot which project I was in. Let's run Notepad.
Yeah, just Notepad's fine. It's just going to be a quick
quick example nice and of an tiny. Interface.
Yeah. So I'm not going to build a system. I'm just going to show the interface I would use, I guess.
What do we type in here?
So I would just have a public interface, and I'd have like cooldown presenter.
So something like this, or an eye cooldown presenter.
See if I can.
It's too tiny. There we go. Oh, look at that. Notepad lets you zoom now. I didn't even know that.
That's quite nice. I'll see if I can. I'm still seeing it through this channel, so I'm a little bit.
Delayed. Oh, okay. Sorry, I forgot there's a little delay. So you got like an eye cooldown presenter, and then what?
Yeah, I would have a boolean property, and I would have it just be set only, and I would call it something like busy or on cooldown or something. Like on cooldown is probably a good one. And then I would have a float for cooldown percent, and I would give that a setter as well. So the trick would be that it's a set and not. It wouldn't be a get and set. It's purely just the set property.
Oh, okay.
This is where I find the what's particularly interesting.
In fact, this wouldn't be there either because we're in an interface.
Yeah, exactly.
Okay.
So the idea is that you would have a get component call in your awake for this component, which is really weird and doesn't have any values other than a set for true false and a set for 0 to 1. And then I would just replace my places in my code where I mark that as true false and where I set the percentage. And then that allows me to do is write a Text Mesh Pro cooldown presenter or a help or a bar based cooldown presenter. And it just implements this, and all it does is set the either display the percentage or display the a bar fill amount or something. And that way I can hot swap out what the visual representation is. I keep all of the logic and all the stuff you already have for cooldown calculation and resets and timers. But the bit that I don't want to reference is I don't want to write the word Text Mesh Pro into my cooldown code. Because from my perspective, Text Mesh Pro is one of those things where someone will come along to me later and say, we don't want it to be text-based anymore. We want it to be an image slider, or we want it to be an audio cue or something. And you can extend that so that you can add things like sound effects and things that happen when the cooldown percent reaches 100 or reaches 0 or whatever else. And all of that constitutes presentation. There's no logic to it. It's entirely listening to the two things being set, and it can fundamentally change. So that way, there's zero visual representation in the core logic in the controller layer, and all of that stuff is presentable. So it's not a full MVC or an MV or MVP, but it just purely says anything that draws can listen to this event and change out the implementation without having to go back through my code and change from TextMesh Pro to a canvas group or a image sprite or something, right? That's like, because that's obviously something that is very likely to change separately.
Okay, interesting. No, I could see the argument for it. It makes sense as a design. I could see.
It does help that it's worth noting that I literally work with a designer. So
Yeah.
I have one person who does that stuff. I give them a contract and they can do what they like with it.
Yeah.
And I can maintain the rest of my code separately. Some of these things are less important if you're fundamentally going to be the guy doing it. I still like to draw the line for my own practices, but it's not as important if it's literally you going to be making that change.
Right. No, and I like I like the line in general because it allows us to do some other stuff too, like make this stuff work with plugins, right? So you can
Well,
swap
like
in
an
your own
example I've used,
UI.
right? I've used this exact example for a input box. So the example was you had to type in some values and click a button and it would then take that input. So if I was basically saying, what is your name? You type in, press go, and it to set a name. And I would build a contract like this, which just has a, input string as the only part of the interface. And that is it. As weird as it sounds, it's just an input string. And then the presentation layer I would use would be a standard TextMesh Pro input box. And so I would just say, get the value from the input box, do the rest of my code with it, and off I go. And then later on, I got a requirement to say, can we make this voice activated? And so I did. I made a different presenter that would use the Microsoft speech engine, get what you said, and fill in the text field. And all of a sudden, I've just hot swapped out a typed in based input for voice control, and none of my logic changes. Because conceptually, the contract says, here is a thing which knows how to provide a single string of input. And that's the presentation. Because as far as I'm concerned, that's the bit that faces the user. The rest of my code doesn't care where the string comes from, as long as it gets a string. And so that way you can choose anything from reading text files to clicking items in a menu and passing in the name of the objects to typing in values. And all of that is technically presenting data that goes into a system that all it needs is a string. So choosing where the line is very important as to how maintainable those sorts of changes are,
Yeah. And knowing where the line is or even having a line can be important too, right? Like
yes,
the
even just
default
having
is
any
to not have any lines and not even
yeah,
think
yeah.
about it and have everything reading everything in your controller code is reading the text of your labels to control stuff, right? Like
Here's one of the
that's where you
simplest
want to watch.
examples. You just take an example where you've written something like debug log message, debug log message, debug log message. You have basically written the word debug log 5 times throughout your code. So that is very strongly coupled to everything. And if you decide you're going to have all of this right to TextMesh Pro, every single place you've written debug log, you're going to have to go back and change it to textmeshpro.text equals. If you just made a single function called display and you passed in whatever it is you're displaying, you could at the bottom write debug log display value. And then later on, you come along and say, you know what? We're going to print this to TextMesh Pro. You would have one place to change it. And other things later on, you might want to say, how about we go to TextMesh Pro and the console and we save it to a file, one place to change it. So that is a responsibility that you want isolated to one location. And we'll get to the
Yeah.
other solid principles, which will show you how to take it out of the file altogether. But for now, if you just think about things that you've found yourself writing repeatedly, if you just wrap it in a method and just have one place, then think about how hard it will be for you to change that decision later. That's the number one rule. Just figure out, will this be a pain in the ass to change later or not? And if you can make it less awkward later, you've saved yourself a surprising amount of struggle.
Yeah. I would caution that though and make sure that you only do it for things that you may realistically change because I think when
you can overdo every single one of these rules, definitely, to the point where you cause more harm than good. Yeah.
Even at like debug logging, like 95 to 99% of the time, people are not gonna override that and change it, right? Like in certain types of games, they may, but I mean, most of the time they're probably not, right? And I think that's the case for everything. Like it's very easy to, and I've seen people do it where they just default to abstracting everything that exists just in case they want to swap to a different vector 3 implementation or something fucking crazy.
Well, that's the Yagni thing, right? Like all of this comes down to, do you need it?
Yes.
So don't preemptively add these layers. Add these layers as and when you need them. So for example, like this is the other thing too.
Or when you know you're going to need them.
But even then, I often don't do that. Like if I have a multiple scenarios I need to use, I will start with the inline version. I won't even write the abstracted version at all. And then when it comes to the second implementation where someone says we are changing out this system for this system, I will then say, hang on a second, this is something that is prone to change. By the definition of I literally got a request to change it. How do I turn it into something that is abstracted out and then make both of these versions implementations and use the new one and then move on? So I'll often not even abstract it out until I literally have the second requirement already come in that requires me to have to make it abstract.
Yeah, I think that's a good time to do it too. So it's very easy to think that you're gonna need something too and just be wrong. It's happened to me hundreds of times, and I'm sure everybody else. So you want to jump on to the next letter? Move on to O. I don't know if you saw the chat too. People are saying that some people on forums advocate avoiding solid for game development.
I would strongly disagree with that.
Yeah, I would too. I can see the argument, and I've heard the argument, and I think a lot of it comes from just examples that aren't really relevant, that confuse people into thinking that it's not for them, that it's only for these very specific examples that don't apply and don't make a lot of sense in game development. Here, let's switch back.
I find that test-driven development is a great example of this. Is people will often incorrectly learn how to write tests. They will write tests badly that are hard to maintain. Then they will complain that tests are a bad thing to write because their ones don't work for them. And then
because their tests break every time they change code.
And it's like, so the idea is, oh, well, tests must be bad because it's bad for me. And I find solid principles are just principles. They're not solid rules or solid guaranteed steps every time for perfect software. There's some principles that help you reason about code in a way that makes your life easier. If you're not finding value from them, there's one of two scenarios. Either they're useless to have or you're doing them wrong. Realistically, if they're no value to you, don't do them. But if they do add value, then use them. And I would argue that if you're finding solid principles are not adding value, you don't understand them well enough and you're applying them incorrectly.
That is wrong, but that's usually the case.
Yeah, because again, they're not like a specific. Nothing about the solid principles says always do this thing every time, never do this other way. It is basically in your best interest to separate concerns of your software. Don't put 5 things in one file when you're likely to change one of them and have to rewrite and go through all the code and read it again. If you figure out there's 2 very clear lines of things that will happen in your code, separating them as distinct responsibilities kind of just makes sense. This might change. This might change. Now my code is easier to work with. That's all it is. There's no reason why that is wrong to apply. You might choose it doesn't apply more or applies less in certain situations, but realistically, to say it doesn't apply is kind of nonsense in my opinion. It is just a principle that will help you. Use it if it helps you. That's all I'm saying.
Yeah. Well, and I think one of the just to push back, one of the concerns that you're going to see is people talking about performance, right? They're going to think that because you're using some enterprisey techniques with finger quotes, right? That you're going to be getting bad performance suddenly.
Yeah, and I'm pretty sure we covered this at length in our last talk, is I very clearly drew the line between event-driven and loop-driven software. And a lot of the concerns about solid principles causing performance issues and causing overcomplicated architecture come down to people misunderstanding that when we're saying design your code around these things, there are certain cases where you don't do that. And there's certain kind of hot paths in your code where adding extra architecture will be bad. We've literally said this in our previous videos. So when I'm saying solid principles is a good idea, there's a fundamental difference between drawing lines that'll make your life easier for maintaining code than just arbitrarily putting everything in boxes and making your code harder to run by going through multiple layers. That is not the same thing. And admittedly, it comes down to experience to know the difference. But I'm sure if you give solid principles a fair shake and read what they do and read what their point is, and then try to apply them logically to the systems you're in, you'll see that they're not regiments about how to make your code messier or slower or whatever. They fundamentally can add value in the cases you apply them.
Yep, that's 100% right. People should do it. All right, let's jump on to open close.
Yeah, I'm just gonna go for a second to the bathroom, and I'll be back, and I'll join you for this one. So feel free to introduce the topic before I get back.
Okay, sure. So the open closed principle, as it's up on my screen, is that objects or entities should be open for extension but closed for modification. I'm sure they have, what is this, an example of area calculation and let's see, was this squares and circles trying to calculate area. But I just want to talk about it briefly on what it actually means for me. So in general, following the open close principle involves making your classes extendable or extensible so that you can have them do extra things. And this is usually done through two different things, either abstract or virtual methods in the class, things that can be overridden by a class that's inheriting from it. So like you've got well, let's say you've got let's say you've got like an actor in your game or an entity in your game, and then you've got an NPC. The NPC may override how it deals with death. So maybe you've got an actor and it moves around and it dies, and you've got player actors and NPC actors. NPC actors may override death and do it a different way, and you don't have to add in a whole separate class for it. Another really, I think, well, hey, Jason, before
Welcome
I dive
back.
into more examples.
Sure.
So talking about open close principle and
Yes.
the way that it's actually, or the way that I actually see it in real life, which is just essentially classes that are extensible either through virtual or abstract methods or through events. So those are the two general ways that I see this happen. And it's that we have a class that either fires off events when things happen, and then our other classes can then extend this by registering for it. So it could be like an enemy class or an enemy health class or something that then gets hooked up to health bars or other indicators whenever it takes damage, right? Or I've got ability effects that all do the same type of thing. I don't know if that. Let's skip that one. I'm kind of curious. What types of examples do you see with open close? Like, is it generally?
I guess.
Well, go ahead.
Before I answer what I'd use it in or how I've seen it used, let's start with what the point of it is, right? Why is there an open close principle, and what does it mean? So
seems like a good idea.
As the description says, objects or entities should be open for extension but closed for modification. Now, keep in mind, each one of these principles was designed to solve a problem or to make life easier in certain situations. What problem is this solving? Well, in my mind, the problem this solves is a very common one, which is you will write a system where you build a character and they've got a sword and they're swinging a sword. That was the design of your application. It's a sword based application. And then you come along later and you decide to add a gun. So what you do is you remove the sword and you add a gun, and you've changed your code. Now, to do that, you had to open the existing player class, remove the sword code, and add the gun code. And that seems fine. There seems to be no problems there. But a common case that you'll come back to is at some stage you'll change your mind and you want to add the sword code back, or you want to add another kind of weapon of some kind, like a magic spell. This may not seem like open close, but wait till I get to my conclusion. The point here is that because you're living in a world where your code is open for modification, that is the negative. What happens is you are fundamentally opening the file, you are editing it to add new features. And that means by design, you have to remove old features to add new features. And so your code starts to become very tied to the current implementation. And this means that it's a pain in the ass to go back to older versions. And you also can't test multiple different versions at one time. But if you design your code so that it is written once and works, but you can plug in different things, aka extend it without modifying it, it is now open for extension, but closed for modification. You don't change the code that's in it, you just change the way the behavior functions. And probably the quintessential version of this is the strategy pattern. It's effectively saying you could write an algorithm, as silly as this sounds, if should shoot, shoot. That is a very nondescript, doesn't explain anything about your code kind of system. But it is an algorithm. It is a rule. If this happens, perform this action. And the thing is, that code could theoretically be closed for modification. You could lock that in and say, this is the always algorithm I'm using. But the input, the if should shoot, is going to be a mouse click or in range of enemy or AI can see enemy. Fundamentally different logic. And the shoot can be fire gun, fire laser, throw bomb. Maybe it doesn't actually shoot at all. Maybe shoot is just a bad name for it. Maybe it's swing sword. It should be attack, for example. If should attack, attack. It doesn't matter. But that contract between if this, do this, that piece of logic can be written once, never changed, and yet you can still get infinite complexity out of different behaviors out of it. So long story short, open close principle states you should write your code in such a way where your business logic, your behavior is sort of conceptualized in a way that you don't ever need to change it to change its behavior. That you can add new behaviors to it without actually having to rewrite the code. That's sort of the fundamental rule and why it helps you.
Yeah, I think that was a very, very good explanation. That was nice.
And that's why it comes back to what you're saying, right? Like that's what a virtual method is. A virtual method is if something happens, do this thing. And you don't want to write the answer that's always going to be used in the code because to change that behavior, you have to modify the file. But if you make it virtual, which is one solution to this problem, you can extend the behavior and override the existing one without having to rewrite the old file. So the whole point of this principle is just simply it's if your code has to keep being rewritten, there's probably a design problem there. You should realistically be able to compose your application out of components. And if a component is the wrong one right now, you should be able to unplug it and plug a new one in. So you take a game, you need to save your data somewhere, you need to create your characters and load scenes, and these are all like discrete things. And we talked about how in the first principle, um, you each thing should have a single responsibility. Now your business logic is combining responsibilities to do a thing. If character dies, send score to help to high score system, save players high score and whatever. None of these things say anything about the implementation. Each responsibility is alone, and then each responsibility can be swapped out if you follow the open close principle, because each individual thing is locked in as an algorithm for how your application works, and each individual responsibility is isolated. And as we move down to the next letters of the solid principles, you'll see how we can move from just having clean pieces to how you can swap them out as you go. But effectively, keep that in mind. Open close principle is basically about don't rewrite your code. If you're rewriting it all the time, you're kind of getting to the point where you're losing. You should aim to write code such that you can add new features without having to change old features. That's kind of the basic summary.
Yeah, I like that. Do you want to just briefly elaborate for people who might not understand on your so say like your can attack then attack method. Can you just explain how you would use interfaces or something to make that actually work as code so people can understand it?
Yeah, so I guess the idea is that there is a this could be hard to describe, I guess. I actually have, funnily enough, a some code for this, but I don't have it handy. If only I thought about bringing it with me. I actually have. I think I mentioned to you before, Jason. I found out how to do the GitHub repos for packages.
Yeah.
So I've basically built a little set of things that actually do this sort of idea, sort of extract it out into its own packages. But yeah, I guess the idea would be that if you could write the line, for example, if input.get key down spacebar, that would be a line of code that would say if spacebar is pressed, and then you could do something. So if you say if spacebar is pressed, jump. That could be a piece of code you write. What you've done is you've said, if specifically spacebar, do the jump action. And so what's happened is, in order to make anything other than the spacebar cause jump, you have to physically modify that code. If you can conceptualize and kind of abstract out that idea into if should jump, jump, that should jump can be its own method, its own interface. It could be anything else, this sort of action. You can then provide different actions. So if you can find a piece of your code that can be extracted into a conceptual contract, the algorithm stays the same. So if should do something, that's a fairly robust algorithm that'll stay forever, right? And you can provide different inputs and different outputs.
Yeah.
I guess we can probably come up with some actual code examples at some point down the future, but it's kind of hard to on the spot.
Yeah, it is. So I'll have to do that soon. Just come up with some real examples, diving through these again. I think it'd be fun. And I think you gave a really good explanation of it too. All right, shall we jump on to the L?
Yeah, this one is a toughie because unless people really understand the others, this one should kind of be last.
No, this one has the best definition ever. Let Q of X be a property provable about objects of X of type T, then Q of Y should be provable for objects Y of type S, where S is a subtype.
It's so easy.
All right, so we'll go on to O, or I, sorry. Do you want to skip ahead of Liskov and jump back?
No, I think we can give a fair shake at this, right? It might still be difficult, but we'll try. Right?
It might, but I mean, there's no harm in bouncing out of order. Seen Uncle Bob do it plenty of times.
That's true.
His argument was that they're only in the order that they're in because of the name. It made a word.
Well, funnily enough, it actually was. When Uncle Bob made them, he didn't notice it was a word. It was actually somebody suggested to him to switch it around.
Yeah, I heard that. Yeah. So they got switched around just to make the word.
Yeah, just randomly for the name. Yeah. We might as well go on order because realistically, it's not like anything we say later is probably going to help explain this one. They're kind of standalone anyway.
Sure.
Let me see if I can give a good example of this. So the one that often people tend to use is shapes again. So I'm going to try to avoid that because I don't think it's particularly valuable. Let's see if I can come up with something better.
These Super Mario characters?
Yeah, if I can. I guess. I guess it comes down to the general point of this is, again, keep in mind each rule is designed around solving a problem or making code easier to work with. And the point of this one, without getting into the fancy, silly terminology here, is the idea that every component should be able to comfortably replace anything that it's using. So if you've come up with a contract for something that says if should jump, jump, whatever it is that replaces that should jump, everything about it should work. As weird as that sounds. So the kind of the symptom of this is if you have an interface that describes a behavior and you create multiple versions of it, and you tend to just leave things behind that you leave blank or not implemented, you're probably using the wrong interfaces because each new thing that comes in doesn't do the previous job. See, it's really tough for this one because it's effectively describing incorrect implementations of interfaces. But how do you describe that?
Well, I think part of it too is it's explaining incorrect inheritance, right? So like actually diving into like a Super Mario example, you've got like the little Goombas, right? They walk around, or you've got some flying bullet enemies. Right? If you had written your enemy class as these little Goombas that walk around and they've got code in them to check for whether or not they're grounded and whether or not they've bumped into a tube or something and need to turn around, and then you inherit the bullet class from that base enemy class that's got that, I would say that's a big violation of it, right? Because then you've got things that are expecting to be able to check, like if you walked into something, and those no longer apply. They don't make sense for it, or whether or not you're grounded and should be falling, right?
Like I think volume is probably, so the example in that they're probably using is volume because that's always the answer you give. Because I think it's a probably clear one. Is it's effectively if you made something called a shape and it inherently has a field called volume, a shape's volume. That may logically make sense to you as a thing. Oh, shapes have volumes. That's just a property of my base concept of a shape. But realistically, volume isn't always the same per shape, especially if you're talking about 2D versus 3D. And conceptually, how you work with that shape is very different. And so you can't replace a system where you can just swap out a 2D shape for a 3D one and expect everything to work the same way. And that's the fundamental principle behind the Liskov substitution. Is realistically, if you reason about taking one component out and replacing it with another one, that other one should fulfill all the requirements that of the thing it replaced in a way that makes sense, and it shouldn't have these weird scenarios. Like, for example, I think Unity technically breaks this between the difference between vector twos and vector threes. And yeah, well, exactly. 2D shapes don't have volume. That's kind of the point, right? It's that you can technically cheat by having area, and you could say, oh, well, area is volume effectively as far as 2D shapes are concerned, but it's not. Fundamentally, how that works is different. What impact that'll have on your render is different. What impact that'll have um, on your sort of collision system will be different. You could cheat the system by in the place where it expects area, you return volume, but that's going to break things somewhere in your code. And that's going to confuse anyone who tries to use that system because they won't know whether the shapes are, you know, are basically lying to them about how their implementation works. So Liskov substitution is saying if you have a system where you've extracted out an abstract kind of concept that represents these shapes, everything needs to conform to what that is. And if for some reason you're finding stuff are not shaping well and you're sort of having to cheat to make it fit, your abstraction's wrong. And you should end up with different abstractions that do different things. So it's sort of more of a warning that if you start to see these things happen, you should abstract in a way that doesn't allow those things to happen.
Yeah. Have you seen any really bad violations of this, or think of anything that pops into mind?
Well, the only one that really comes to mind is that Unity do allow casting from vector twos and vector threes fairly liberally, and conceptually, there's a lot of scenarios where they'll use a 2 or a 3 where you need a 2 or a 3, and you end up with these scenarios where the z doesn't actually mean anything in the context of what it's doing, right? You'll use a vector 3 in a 2D context,
Yeah.
but they'll just sort of ignore the z, and that's completely defeating the contract that they're promising, where you expect the z to be a valuable property of that feature. Um, that's probably the only thing that really comes to mind. I guess the other example is if you built something called a character, and you had a property on it called rigid body, and that implication is every character should have a rigid body, but you might actually be using a rigid body 2D or recursive, and that's going to fundamentally change the way your code works, and it might be confusing and make your code work incorrectly. Yeah, this one is very tough. It's one of those ones I think I'll actually try to go away and come up with a good example that's game related, because it's it's one of those ones you just intuit over time and notice the kind of it's basically like a code smell. You can kind of spot it, but it's very hard to visually indicate it. Yeah, it's not the end of the world if you don't understand Liskov or if you're not using it, um, because realistically, it's one of those things that's more a warning that things can go wrong. Realistically, if you follow the other rules and get a handle of how they work, you'll find yourself just kind of intuitively not making Liskov substitution mistakes.
Right. Yeah, and I think you'll find if you are making them, you'll know because you're gonna end up with a bunch of if statements in there checking to see if the thing that you're working on,
Casting the types and stuff.
yes,
Yeah,
is the different subtype, and if it's not, if it is, then do something different in there.
yeah,
And you'll start to find a lot of that behavior going on where you have to
yeah.
special case based on what subclass it is. That's when you
That's a
know
good point. That's like the biggest indication. If you ever find yourself writing if is type of this, then do this. If is type of this, do this. If is type of this, do this. You're like, hang on a second. You really need to know that information for some reason, but you're hiding it in the interface, but you're also then exposing it after the fact, and it completely defeats the contract that you're making.
Yeah. And it's also often a side effect of heavily violating that single responsibility principle. Is you end up putting too much stuff into one class and then violating Liskov as soon as you try to inherit from it, and then things get to be messy quick. Yeah. You gotta watch out. They all kind of compound and make a mess. We're on to eyes, I think. Sorry, I had to run away for a second because a package came and dogs went insane. And
yeah, so I is the interface segregation. I guess, do you want to? Oh yeah, I already have it open.
Yeah, it's already up. A client should never be forced to implement an interface that it doesn't use, or clients shouldn't be forced to depend on methods they do not use.
Yeah.
You shouldn't be. Yeah, I mean, essentially, you can tell if you're violating this one if you're going in and implementing a bunch of empty properties and methods into implementation. So you add an interface onto your class, and you hit implement default members, the little hotkey there, and then you leave them all blank.
So for example, you might have in a game context, you might decide to make a NPC base class, and all of your NPCs will extend from this sort of character base or something.
Yeah.
And so you think, oh well, I'll just put character related stuff in my interfaces for this. So your character interface might include talk and equip and have an inventory. Then you might have attack and eat and all this other stuff.
Take damage.
And then later on, and you're like, but hang on a second, my average NPC isn't equipping anything. They're not attacking anything. They basically just need the talk functionality and maybe the inventory. So rather than build this set of promised contracts that have no behavior, and then when people try to quiz and go, oh, get all characters, then all attacking characters tell them to attack this, half of them will just sit there and do nothing because they're not actually capable of doing that behavior. You're leading to this weird scenario where both the code who's talking to characters is confused because it's not really getting everyone to respond the way it expects. But even more so, if you just want to make a new character, you're like, oh, I'm just going to make a new NPC, put him here, and he'll have a shop and he'll sell apples. And you just go create character, and all of a sudden the code asks you, oh, by the way, now tell me, what's his method of attack? What's his inventory look like? What type of way does he heal? What kind of armor is he wearing? You're like, hang on a second. I just need a guy who can stand there and sell apples. Why do I need to implement all of this behavior that I don't need? And so instead of having a character base which has multiple behaviors, you can split that up quite comfortably into a vendor who maybe he has selling related stuff, and a fighter or whatever, and maybe someone is a fighter and a vendor, and you can have both of those multiple inherited behaviors on one character if you want, but don't make one character have to rely on all this extended behavior that they don't actually care about.
Right. Yeah. I think of that like an attackable interface is a really easy example there, because you've got a vendor and it does not implement the attackable interface, and then you have these other attackable standard NPCs that do, and maybe you've got walls that do, and the attackable interface just has like take attack and that's it. Right? And it's a single little interface that does the one thing, and that's kind of, I think if you look at interface segregation principle examples, you're going to see a lot of small interfaces that do one thing or a very, very small number of things. A lot of the time they just implement a single method call or a single property, right? Where they're very small, so you can mix and match them and not have to implement them like you were saying, essentially.
And this also is another really good side effect, which is, imagine if I made something called a character. I encapsulated the fact that a character can attack, die, and be healed, and receive damage. These are the features I've given a character.
Yes.
Well, if I want to then make a destructible crate, I will make a crate and I will give it the behaviors. Destructible, take damage, and whatever. But I can't reuse the character functionality because it doesn't attack me. But at the same time, it is sharing some kind of basic behavior. What if the character was actually using a damageable interface, and when it receives damage, it lowers its health, but the crate keeps the same damageable interface, but instead it breaks when damaged. So you get to leverage having one interface that has two different sets of behavior, because you've isolated what that interface does.
Right.
And what's really cool about this is you could say, select all damageables in the area, damage them. And you've never said whether it's a, lower health, and you've never said destroy destructible vases and crates. You've instead said, get all things that can receive damage, give them damage, and let them figure it out beyond that point. And so you can leverage stacking multiple behaviors together to make more verbose behaviors. So don't have things that don't need to know about attacking extend from interfaces that just need to know about receiving damage. So small interfaces stacking together.
And I think in that same vein, like your crate wouldn't need to know about moving. Yeah. Right? Like your character is going to have some sort of way to move and some sort of system to move. And if that's all in a base class or an interface that crate is reusing, then it's, again, I'd say just wrong in general. And yeah, it leads to problems.
Yeah, and keep in mind, like the point of this stuff is to make your life easier. And ask yourself what benefits that gives you. Like one of them is it'll be easier for you to make really cool advanced systems because you can say, like, receive water, as weird as that sounds, but the implication being you give a character water and it increases their water meter so they can survive longer. But maybe you make a cup object and you decide to give it the same add water interface, and so all of a sudden cups can fill up with water when it's raining. You never thought about that when you first made the interface. It was designed for characters to drink, but realistically you could now put a character and a cup under a water fountain. The cup will fill up and the character will drink the water. Like you can leverage these really cool interactions between interfaces if you try to think of an interface as a promise to adhere to a certain contract and not the sets of behaviors this thing does. Yeah. So there's a lot of really cool advantages you can get if you start to think along these terms.
Did you see the last question in chat? About he said, do you have to be careful about creating too much inheritance with interface segregation, like having a damageable, I assume like I damageable character, or maybe it's even a base class, a character and then an AI character? I would say if the damageable is a base class, you have a huge problem. If it's an interface, you have less of a problem, but I would still probably not.
I would err on the side of it. I don't think there is any downside to having two specific interfaces, because if you have too many really small interfaces, then just make another interface that is a composite of a few of them and make that inherit from those, and then use the more specific one if you have to.
That's funny. That's exactly what I do, and I feel bad about it. But it's mostly I do it on classes that are already too big, and I'm trying to shrink them.
Yeah, I do the same. Like, it's basically the idea that I would have something that is damageable, movable, and can hide and show itself, and something that has a health system of some kind. And then I would make a base, prop object, and a prop would extend from damageable and, maybe placeable or something. But then the player would have a base sort of actor is what I use for that. An actor would have damageable and other stuff, but it wouldn't have that. They would have some crossovers, but not all of them. So I would kind of encapsulate a subset into a nicer name, effectively, that I can extend from.
Yeah, let me show you one of mine from some stuff that I've been refactoring. Let's see it. My beautiful list of sub interfaces. Just a lot, because this class is just way too big. Can you see it on screen yet?
No, it's still our faces. Here we go. Oh, there we go. Yeah.
Okay. Yeah.
Oh, nice. You use the I can and I have. Yeah, I started doing that myself. I think it reads nicely in some cases.
Yeah, I find it a lot easier to just understand exactly what it's doing. But I basically add a big interface, pop things on, and then split those out into sub interfaces, into as small of interfaces as possible. Like, you know, I don't know what I have weapons has. Primary, secondary, ranged, and ammo. Bam. Eventually, again, all of these things that get split off into smaller classes, because this class is just way oversized. But it's a nice, easy step to make it all testable, and then start splitting things out. When you have these small interfaces, it's so much easier to work with than trying to pass one of the comments there. Class.
Someone says, would that violate the SRP or single responsibility principle? I would say no, because I want to point out here, this is an interface contract that explains like behavior. So that's saying I can have certain behaviors.
That said, I want to point like this class and where this interface is 100% violating single responsibility.
Yeah, I can imagine that tends to happen when you, especially I've noticed that's one of those things I've kind of leaned back on a lot. I've noticed with game development, character controllers specifically tend to be this nexus point of such a large amount of behavior that it's a lot harder to maintain some of those conceptual rules than if you were doing a banking system. Yeah. So there's certain things I'm a bit more lenient on when it comes to game stuff, because you just have to accept the fact that there's just a lot of individual systems that deal with whether a character can move and animate and attack and talk to things and have inventories, and it just tends to be too all encompassing that you have to choose to fight your battles. And that's one of those ones where sometimes you just have to accept there's certain limitations to that kind of design.
Yeah, in this case, it wasn't so much a limitations, just as it hadn't been thought about. Like when I dove into it, there was no interface initially, right? There was just a big giant mega class. It's like, all right, step 1, add an interface. Like step 4 or so was split that out into a bunch of smaller interfaces. Right? Yeah. Still a long ways to go, but yeah, you can get the idea of you can kind of combine these up and build into one big interface. I would, again, minimize this. If you're doing this, you probably have too big of classes like I have here. But there are scenarios where, yeah, you could have maybe 4 or 5 different interfaces on a class and have it totally make sense. Yeah, but try to avoid having hundreds. It means your class is too huge. All right, should we jump on to dependency inversion?
Yeah, although I think we actually covered this another day, but yeah, we'll go over it again. We did literally, we talked about this probably the first stream we did.
Yeah, I think talk about it a lot because people get it mixed up with dependency injection, and sometimes people think it's impossible to do and don't realize that it's can be as simple as passing a parameter. A lot of the time, your dependency inversion is just passing parameters into things. Here, I'll read it off and then I'll let you explain it, because I feel like you're much better at explaining these. So the entities must depend on abstractions, not concretions. It states that a high-level module must not depend on the low-level module, but should depend on abstractions instead.
Yeah, so I guess probably a good way to describe this is that by nature of design, the way things tend to work is things tend to have a relationship, which means the rules about what governs how something works tends to live inside of the thing. So a lot of systems would have something like, if I have an attack, I'm going to attack with a weapon. So my attack method has to know what weapon I'm holding. And so the kind of logical way to do that is you create a person class, and inside the person you create a weapon, and then in the attack method you do something with the weapon. That's sort of the logical, obvious solution, right? But the thing is, the way that code works is now all entities know that weapons exist, and they also know which weapon they're using. But if you think about it, realistically, it should work the other way around. You should be saying characters can attack and they can use a weapon to attack. It should work in the way where you can provide different means of attack, but attack is the thing that should be abstract. But what happens is, because you end up having to put things inside of other things, code tends to get more specific. So it is or there's an army which has characters which have weapons, which happen to have, some of them have guns, and the gun ones use a particular kind of ammo, which then attack. And so this entire chain means that this thing up here knows about all of this stuff down here, because it has to. Everything knows about what's inside of it. And so the flow of dependency is going from these high level modules down towards the lower ones. And everything has to know about each other in a way that sort of leaks implementations. But imagine you had a character who had this attack ability, and he received as an item thing to attack with. So now character says attack with, thing to attack with. He doesn't even know what it is. So now you can create a character, create a thing to attack with, give the thing to attack with to the character, and he doesn't actually know anything about it. So you've got the freedom to change this up as many times as you like with lots of different implementations. And you don't have to rewrite this character class. And this brings us back to that freedom of the open close principle, right? Is that you can write the code once to say if should attack attack. How you do the attack, not my concern. I will provide that dependency later. The dependency inversion is instead of having the character rely on the weapon, you move it out, and so the character relies on something to give it a weapon, which means that it's flowing up this way rather than down that way.
Right. Well, and it's relying on that abstraction of the I weapon or I attack or whatever it is, right? The I thing to attack, I think, is the term that you used.
Yeah, and so this is sort of the fundamental principle behind almost all design patterns. So, for example, you might write some script that says, when I click the mouse, place things down. So it's good. When I click mouse, place. And you're painting trees onto a landscape. There's two concerns there. What do I do to cause, what is the action I perform that indicates that I want to place something? And what am I placing? So the first implementation of that class might be if mouse click, do raycast, place item. But you're now writing into that script tree. So now you've got a tree placer. And forever and for all eternity, it places trees. But if you instead took that out and said, get me thing to place, and you passed that in, you could now say, if mouse click, do raycast, place thing I have to place. And that thing can be passed in later, starts with trees, maybe I move on to houses later. But now you could do the same thing with the input. If I do thing I'm supposed to do to cause input, then do raycast, place item. So you take that out and you start with mouse click, but maybe it's spacebar, maybe it's a countdown timer, could be anything.
A network message, right?
Exactly, right? And then the third one is you do the raycast thing. Well, are you raycasting specific layers? Are you raycasting onto round surfaces? Are you placing it based on the normal of the surface, or are you just placing it flat onto the surface? These are all business rules, and if you write them into the code, you end up with a place onto surface but always flat script. And that rule is locked in and written into the script. If you instead provide that as a dependency that's inverted by moving it out and then passing it in, you can decide, what do I do when I have something to place? So now you've got this really weird algorithm which says, if should place something, get place to place it, get thing I have to place it at thing I'm going to place it at, and use this method to place it. And it says nothing. This is really vague and abstract thing. But now all of the dependencies have been removed out, and this chunk of code could live forever, and you can pass in different things. And now you could say, I could take that file and make a place onto sphere, painter, sphere painter. And I could make another thing which is, landscape painter or grid painter. And the only thing that changes is I'm passing in, what am I painting onto? Am I painting into a grid format? Am I painting onto a sphere? Am I painting onto a flat plane? And they're the rules. They all inject in. And then on top of that, I could choose, what am I painting? Trees or houses or dogs or cats. So now I can have infinite complexity and write systems which can paint any type of thing onto any type of surface, choosing different rules, and I don't have to rewrite my code because the dependencies are not written into the code, they are injected into the code. So they are inverted effectively.
Yeah. I was wondering where you're going with the painting example, but it actually makes sense there for that.
But it's because I've literally done that one. I found like I've done an example of this for an AR application where I wanted to test this in the editor. So I painted by pointing the mouse and clicking, but then I reused 3/4 of that code and changed the raycaster to be a transform forward from a ray generator from a character's head. So I could keep the entire painting system. And now I'm doing it by using first person look camera. And then I can take the same code and replace it with a click on the screen by using a camera.screenPoint array. And so the painting system still works, regardless of whether I'm using first person camera or whether I'm using a mouse. And then the painting can be, painting by holding and dragging lots of things, or in a different system, I had it paint by, individual clicks. And I was reusing the majority of this code every time because I isolated the rules and sort of stacked them in a different way,
Interesting. Yeah, when you started with it, I was like, when do you use this? But no, that makes sense. How's that?
Well, it boiled down to is that I was building a system for painting items that I used both in AR and VR.
Yeah.
And so I didn't want to have to. And the thing is, for people who don't know, you use raycast hits for most things when you're doing Unity raycasting. But if you're using an AR system like AR Foundation, you're actually using there's an AR hit, which is a different object with different positions. It's not like you don't get the same normal in the same object. It's actually got different planar stuff. And so I didn't want to have to write very explicit. This is the thing which knows how to paint objects onto a flat surface in AR. This is a thing which knows how to paint onto a flat surface in VR. 3/4 of it's the same thing. The only bit that changes is on do some kind of hit of a raycasting thing, get me back the positional data I need. Given that positional data, given an item I want to place, figure out how to do it. 3 different components I can stack together and do infinite things from it.
Yeah, that's pretty cool. It's I think a really good advanced example of the principle in general. Did you see the one on the site that they have is very simple. They're just doing essentially a database connection interface instead of injecting in raycasters and
stuff. Yeah.
all that. They're just injecting in a connection and then swapping them out.
I've got a practical example of this. I've literally done this earlier today. I was building an API, which at the moment we're using DynamoDB. So that's a NoSQL database, part of the whole Azure, not Azure, the AWS stack. Yeah. But I don't want to test against the database because if I have to do things like update entities and delete entities, it's causing a load of mess in the database.
Right.
So I used a separate pattern called the repository. And the repository effectively says, this is how you save and update an item. And so I made 2 versions. I made one which just is lists. It's basically just a literal list of ducks, we'll say. And I can add to the list, remove from the list, update an item in the list, delete an item from a list. And then I have another version, which is the exact same contract, but except it does it actually to the database. And then in the real version, when I run it live, data goes to the database. When I'm testing, I don't want to go to the database, so I just swap that dependency to go to, here's the saver or the, create ducks class, and it takes in the repository it's using, and it just saves all of them to that repository and updates and deletes. And then when I want to do testing, I say, you know what? We're now going to put in the fake in-memory database. And that's where we're going to live until I'm finished the testing, and we'll put back in the real one.
Okay. So and then that one works just like a dictionary instead of a database.
Exactly. Yeah.
Internally or something. That's a really good use for it too.
And we haven't even gotten to going from repositories to unit of works, and then once you've got unit of works, you can then build services around it, and you can get to this point that your systems can compose in beautiful ways. There's a chunk of code that I should show you off stream, unfortunately, because it's something I can't show here. But you might get a kick out of how I've kind of drawn the boundary lines for that one.
Yeah, I'd love to see it. Check that out after. Yeah, composing things in neat ways that are easy to understand and make shit clean. It's really fun. I have a lot of fun doing that stuff.
Well, for me, I just like the fact that it's like plug and play, right? It's like building your own Lego. I think if you design systems with that in mind, you kind of get the freedom to just play with the result. Yeah. Like you can do some really interesting stuff where you don't expressly say where things go. You just say, I will need to save this somewhere. Here, take the data, save it somewhere. And should I do this thing? Give me a yes or no. Yes? Okay, cool, I'll do this thing. And you don't describe what those behaviors are. You just describe that it conforms to the contract of being able to provide that. A very simple example is in Java, it's called the scanner. But you know it more as, say, like a USB interface. So as far as a normal system is concerned, it takes input from you. And that input can be in the form of a gamepad, or a keyboard, or a mouse, or anything else. And fun fact, if you make a standard .NET application, you can either feed it the input, where you actually, it's called console, so console.readline. It will, by default, read keys one by one as you press them on the keyboard. And that's how a console application works. It's reading the keys you type in and doing stuff with that information. But because that console, or scanner as it is in Java, is a contract which says this thing knows how to provide input in the form of individual keys or strings, it can actually be called by Windows. So you can actually write code which will read a file, take the lines in the file, and pass it to your application. And you never added that behavior, because what happens is Windows will automatically change the dependency to be going from a keyboard that you've got live actively typing to reading a file, and simulating it being a keyboard. And this is because the dependency is a separate thing. So if you write your code in a sense of there is an input device, you can then just run wild and do things that revolve around input, and you can decide how that input is provided later. And that comes back to the humble dialogue stuff I talked about at the start, where I have like the interface that has a single string of input. Anything to provide input. I don't care. I don't care if it's coming from a console, a text file, a web service. I just need input, and I can do my job with that information.
Yeah. Just need some text, right? It kind of reminds me of console piping too.
Oh yeah, 100%. Yeah. It works definitely the same way. You can do some really interesting stuff with that.
There was a question too about dependency inversion versus injection, right?
Yes.
You want to hit on that real quick? Just what the difference is? I know it's easy to get them mixed up.
It is, and I did for a very long time. So dependency inversion is the principle. It is the goal of designing your code in such a way that you're passing in dependencies to work with rather than having the rules inside of it. And dependency injection is a way of resolving those dependencies. So let me give a good example. You might have a system which prints console messages. So you've got this logger and it prints console messages to the log. And the system uses that logger to do those printing. And you might have another system which uses this system that you've made. So you've got a high scoreboard, and the high scoreboard will log to the console all of the different things that it's doing. And then you've got a save system which will tell the high scoreboard that player has killed another guy, give him more points for the scoreboard. And so you'd pass that in. But the player might decide to log things too. So he might be logging, information about where I am in the world and what position I'm on. So you end up with this really weird thing where it's a dependency chain. So user or player needs to know about the score system and the logger. And the score system needs to know about the logger and the high scoreboard. And the high scoreboard needs to know about the logger. And so you end up with this really weird thing where you end up writing var player equals new player, and then inside the brackets you're passing in the score system, and then inside the score system you're passing in the high score, and it can kind of get a bit messy trying to evaluate all of the different things and pass them all in. And here's what's really cool about dependency injection. Dependency injection is you just say, give me a player, and that's it. You write one line of code. And what a dependency injection framework will do is it will say, okay, player, what does a player need? The player needs an interface. Okay, and what is that interface? It needs a logger. How do I get a logger? Well, let me go to the system, and the person who made this system has said all loggers go to the Unity console. So it'll pass in that particular implementation. And so what you do is you build a collection of saying each system goes to this system. All loggers are going to be using the console logger. All high scorers are going to be using the Android mobile high score, and player use those things if you need to. And so dependency injection will automatically work out your dependency graph. It'll figure out, if you ask for something complicated, how to plug in all the pieces it needs and just give you the right answer, as opposed to you manually having to figure it out and pass everything in. But that's not the principle. The principle is dependency inversion. Dependency injection is a way of automating the work that you have to do to kind of resolve all of the stuff that you need to do when you're using dependency inversion. So the TLDR is you can use dependency inversion without using a dependency injection framework. But if you are using a dependency injection framework, it has to have systems which have dependency inversion in them to be able to fulfill those dependencies.
Right. And that's usually done through either attributes on a property where it does property injection or constructor injection.
Constructor injection.
So they're parameters of the constructor. For Unity stuff, it's usually an attribute on there because we don't have constructors. And the other benefit there of using a DI framework, I guess there are two other little benefits. You mentioned on not having to set them up, but it's also not having to go in and change them. Like whenever you make a change to the dependency, you remove a dependency, not having to go delete that out of, however many places up the stack and down the stack. And then also being able to easily swap them by changing one spot of code, right? So like when you say you add the one spot where you wanted to inject it, and then you usually have one spot where you do a little bit of bootstrapping and tell it this interface should map to this class. And then you can swap those to some other implementation right in that one spot. That I think happens less than the whole just having it automatically clean up dependencies and being able to delete and change those a lot easier without having to go in and modify a bunch of other files.
Because that is a pain too, and this happens a lot where you decide to add a dependency to a low level. Like you decide, oh, actually, by the way, this particular small component, I want to print out the value that it gets. So you write an interface, you add to the constructor the loggers interface. And all of a sudden, you have to go back to your factory pattern that you're using and change every single thing that references it along the chain. But if you're using a dependency injection framework, it will just say, oh, it needs a logger now. I'll give it a logger when I'm building loggers, and it just figures it out for you.
Yeah.
There's a lot of magic to it.
There is. Yeah, and it does that all kind of at the startup time, right? It figures out that mapping and those requirements when you launch it, so you don't have to do it.
I will say, though, one thing we didn't discuss, which might be worth mentioning, is why even bother with dependency inversion? What is the point in having all of this separation and splitting up? And I guess the simplest answer I can give is if you have a complicated system, you're eventually going to have some complicated rules in it. So people often use banking systems for this because they're probably the best to explain it. Unfortunately, it's harder for a good game example, but I'm sure you can come up with one yourself, which is if you have a system where someone is trying to take money out of actually an in-game shop is pretty much a banking system, so we'll use that.
Sure.
If you're trying to buy something from a shop, there's a bunch of rules as to whether or not you're allowed to buy something. Do I have enough money? Is the item for the right class that my character is? Am I the right level to use it? Have I enough, reputation with the shop that they'll allow me to buy it? And then if all of those rules are true, do purchase. And in a standard implementation, you would have a buy item from shop, take in item, and you would write all of that logic right there in line. But here's the thing. If you change your mind and add a new system where, on your birthday, the shops will say they'll still sell to you even though they normally won't because they don't like you. You get a special 1 day free benefit thing. You have to go all the way down to the middle of that class and say, or it's your birthday, then do this thing. And so you've had to change that rule inside of the class. And as we've established from the conversations we've had earlier, this breaks the open close principle. This is kind of falling into the category of more than one responsibility because it now needs to maintain knowledge of birthdays, which it never did have to do before. And you start to sort of scale out the complexity of this system. If you instead had something that said, can purchase from shop, and then when you get all the way down to this bit in the middle of the code, you have a shop rules, and you say shop rules that can purchase, take in the person, take in the shop, take in the item, and it'll either say yes or no. And if it says no, it'll tell you why. You can just not think about that again. And if you later on take that rules object and add birthday to it, it doesn't change any of the code for the shop. And in fact, you can reuse that rule in other shops, and you don't have to go and rewrite multiple shops, or you can use the same rule for, renting horses. And it's the same rule system, even though it's not using the same code. And here's where it gets really cool, is if you take that system and you want to test that it works, you have to go and test the whole shop. You'd have to say, am I in the shop? Do I have a player? Can I do this thing? And go all the way down the chain until someone's able to purchase from it. But if you've just extracted out the rule as a can purchase from shop, you can test the shop rules in isolation and add new rules and change them without having to go and new up all the other stuff. So one of the really, really cool benefits of dependency inversion is you can literally test just the thing you care about. You can test, does the shop rules make sense? And then test if that works. And then every place that uses it, it will make sense. You don't have to test the shop and its interaction with a player and its interaction with an item just to find out if the rules work.
Yeah, that's a good example. You reminded me when you're going through this. It reminded me of another example that I want to share that's very similar to when you're talking about rules and stuff. So I've got a let me share. We had a condition class that I think kind of lines up exactly.
That's one of those things which I think every game I've ever worked on has some version of a predicate, some sort of conditional rule system. Every single one of them.
Exactly. Yeah, it's the same exact kind of thing, and just an interface for it, and we just inject this in, so the conditions get injected. They can be we can add new conditions and inject them in very easily too, and just do the same. Yeah. So it's
So you can imagine using this example. It's like can purchase takes in a condition, do the condition, and we've not said whether it's you can only purchase on the full moon, you can only purchase if it's your birthday, you can only purchase if you're the right class, if you have enough money, if you have all of these things can be decided later because that doesn't affect how the shop works. It only affects how the rules are applied. So you've got the freedom to completely change this up, test it, do all sorts of stuff, and your code still works beautifully.
Yep. And we can do all kinds of different little conditions, like having an item in your held slot, right? And you can just add them in and inject them in, and not have to go in and change stuff. So you want to add in these new predicates or conditions, you just keep creating new stuff and just inject them in whenever you need them. You don't have to, mostly yes, you don't have to go back and change things and break things. Because that's, I mean, when we talk about having to go back and change code, the main reason we don't want to do it is because that's when things break, right? When you go in and modify stuff, you go adding if statements in the middle of stuff, and stuff starts to break then as soon as you're changing things, I think. Or the likelihood of things breaking and getting more complex and harder to follow. Especially like when I think about your birthday scenario, like at first it's fine, right? Like you do it and you're like, okay, whatever. My method went from 10 lines to 12 lines. It's when you get 3 years down the road and that's now 700 lines of a bunch of if statements and all these different weird conditions. And now people can't buy crap on their birthday if their birthday's on a Tuesday or whatever.
Yeah. And it's this rat's nest of things where all the systems have to know about each other.
Yes.
So all of a sudden you decide, oh, we're building this new game or this new system, so we want to reuse the shop we've got here. So you take it out. All of a sudden it's like, oh, you can't just use that. You have to bring the birthday system. It's like,
and our
I don't
inventory
want the birthday system. Yeah, I just wanted the thing that does the shop thing.
You need our faction system. You must implement factions to use the shop.
Yeah, that's legit. You must implement factions and birthdays in order to have a shop that can sell swords. It's like, what? When did this happen to my code?
Very slowly and over time.
Yeah.
It's good stuff. So I think we've kind of hit all the principles. Do you want to talk about any other stuff or answer questions, or you want to go take a nap?
Yeah, I think God, it's getting surprisingly late, and this is we do this a lot longer every time. I always forget how long we end up having these conversations for.
Yeah, they're just fun talks. I don't know.
Yeah. I think though, I think we owe the audience next time that we should probably have some code examples. I think it might be easier to get some of this stuff across next time. Some of it's a bit tough. Solid principles are a very theoretical concept anyway.
They are.
And I
feel like it's the kind of thing that you need to watch 5 talks on each principle with different examples before they really, really start to solidify in your head, and then still you're going to mix them up. But I think it's the kind of thing like if you beat it into your head enough, it makes sense and it makes things easier. But you got to see lots of different examples and actually try it out and run through that stuff, I think, before it really settles, at least for me. So yeah, we can do that.
Well, I'm also working anyway on a couple of helper scripts on my GitHub that I'll probably have next week, and I'll demonstrate using some of this stuff because I do a lot of dependency inversion in the scripts I write. So when I come up with a few example projects that just have little scripts that have examples of the separation, we maybe go over it on a stream one day. Sort of practical examples of stuff I've used.
Sounds fun. I'm gonna drop in the chat or the that form link too for the topic stuff again one more time, just to get a couple more votes. So anybody who's watching still or just skipped ahead on the beginning part, put a link to a form for topics on a game dev conference putting together that should be fun and online, and just trying to get an idea of what kinds of things people are interested in hearing about, learning about, or seeing people talk about. So if you got a second, go fill it out. Just to see if AI still takes the lead. I was thinking about the AI side too, and I think I'll probably send out another survey. But when I think of AI, and I intentionally separated it out from machine learning in that survey, I don't know if you saw, but
Yeah.
when I think about it, in general, it leads me to thinking about state machines, behavior trees, general NPC AI and stuff. I was
Mm.
curious if you had any other thoughts or different take, like when you hear just AI in games and it's separated from machine learning. What is it? What comes to mind for you?
Well, in my case, the two I've used the most are quad trees and steering behaviors. They're the two that tend to crop up the most.
Oh, okay.
Mostly
Interesting.
because if you're doing, I often find grid-based stuff is a very common thing. You know, finding some way to sort of have an infinite landscape of items that you can then query against without having to keep a list of 10,000 trees just to work on them. And then for steering behaviors, I just think they're one of the coolest concepts in all of AI, and just because they're so, it's the Conway's game of life concept where simple rules stacked together can have emergently complicated behaviors, and there's just some really cool stuff you can do by doing some really simple vector math, and you end up with like moving fish and flying birds and that kind of stuff. So I find any excuse I have to have really engaging kind of character motion and stuff, I tend to do it.
Interesting.
Um, I think an
That's
example I
why I
had
wanted to
of,
ask you, because I thought you would have like some ideas that I hadn't thought of, and that's definitely not something I thought of. That's
well,
cool.
I'll see if I have a good example here. I'll send you a link to something. I probably showed you this GIF before, but let me see if I can pull this up. Um, steering behaviors. Yeah, that's the second one I mentioned. You're probably more familiar with it. If you've ever seen a simulation that has like a bunch of fish swimming in the ocean, or kind of whenever you have flocks of birds flying in a simulator, that's all steering behavior stuff. I'll give you a good example of a practical version in a second. Let me just see if I can find this GIF.
Cool. I just pulled up the chart because before we wrap it up, I also wanted to see if you can guess what the thing that got the most not interested votes was.
I was gonna say testing. People tend to hate testing.
It wasn't. I was surprised because testing was doing pretty bad at first, but it's actually recovered a little bit, which is a surprise.
Uh,
Not testing. It is augmented reality.
that's surprising to me. That's
Yeah.
actually it's I mean, it's funny. It's one of the most sought after things from a business perspective. It's one that I get the most amount of requests for as a content producer.
Yeah. I see a lot of that too. A lot on augmented and VR, but my guess is it's just not that exciting to work on, or just not that interesting, or just people already that are working on it know it enough that they don't care. Could be the case,
Yeah.
but I was surprised that it was that high, or it could just be that people are flooded with it. Personally, I don't get too excited about augmented reality stuff anymore either. I did for a while, and then I played with it for quite a bit, and I don't know, just got burned out. Like it lost the excitement and thrill. I guess holding my phone kind of wore me out. Cool, but yeah, so AI it
Uh,
is, and then game design. Luckily I happen to know a lot of game designers who are really good, so I'm gonna try to get as many of them as I can to talk about game design, and yeah, do as many AI talks and fun AI things as possible too.
let me know if this link loads for you. I'll send it to you on our thing. You can open it in the chat if you like.
Oh, okay.
That one.
Let's check it out.
I think this one. I probably showed you this before, but it brings up an interesting point when you're talking about AI.
Let's pull that up. And just full screen it. Okay. Oh, whoops, I didn't go to desktop. There we go. Now we're on desktop mode. All right, it's streaming now.
Cool. So yeah, I only bring this up because when people talk about AI, they think about actually controlling characters and characters sort of doing fun stuff. What I want to point out here is I'm using that Boyd's concept, that that idea of AI-driven characters to control the way these little kind of telekinetic cubes work, where rather than like scripting the cubes being in a certain position, each cube has its own little miniature motor, and the motor is just a standard version of Euler integration. It's just a acceleration applied to velocity, and then it has a max steering force. And you can learn all about this if you just literally Google steering behaviors. You'll find a ton of stuff on it. But it makes for this sort of much smoother and natural sort of feeling, like the items themselves have some sort of behavior, right?
And they feel more alive.
Just, yeah, and all it is me literally saying move to this position, but have this like tiny bit of AI to it. And when I say AI, I really do mean like 4 lines of code. Like it's not AI in the traditional super complicated sense. It's just the concept behind give it some sense of personal behavior.
Right, and that's mostly just the cubes having their own behavior and some situational awareness.
Exactly.
Of,
yeah.
So what tells the cube where it wants to go in this example?
So I have a target direction or target position to move to, and then I aggregate forces. So effectively, if you look into steering behaviors, there's a bunch of different behaviors like arrival, separation, cohesion, and effectively the way it works is a cube has a desired force vector, and then various forces are kind of applied together, multiplied by weights, and then they sort of make a new behavior. So I guess the way I describe it as I tell the cube, so I've got a point system. So I basically say, generate a bunch of points in a circle around this point, and then tell each cube move towards that point. And if I just did a straightforward linear movement, they would just sort of snap to each one of those different points, and it wouldn't feel very dynamic. But the reason they sort of do this like swishing fly around is because they have this tiny bit of behavior that says you have a maximum turning force, you've got a accruing your own acceleration, and it just naturally sways because of that's what happens when you have basic physics.
Oh, it looks really cool.
And if people specifically want the code generator there, that's in my GitHub. I pasted it's there's something there called Jason Storey prototyping, and then the prototyping has a section called point generators.
And you dropped that into chat, right?
Yeah.
Okay. Good stuff. Yeah, it looks really cool. I just like the way it's like entrancing watching it. Now you got me wanting.
The thing is that, and that wasn't even for a project, right? That was because someone was on Discord asking about how to make their telekinesis thing better, and I just sort of let me just throw something together.
It seemed fun.
Because it's not.
Yeah. It looks fun. It makes me want to go play with a system like it real quick, and I have absolutely zero use case for it, but it looks like a blast. So it's making me want to do it.
Someone said they missed it in chat. Okay, I'll post one last time. Let's see if I can find my own GitHub. 1 second.
Cool. I'll add it to the description of the video too, so people watching it can just click on it and get through. And I'll drop the Imager link in there too, right after we wrap it up.
Cool. So this is the that's just a bunch of prototyping tools, and there's another one there for core tools. And specifically, if you go into the point generator in there, you'll see literally the script that runs this.
So, I bet I know what's happening. I bet you're getting yeah. Are you getting silenced? Is your link not showing up? I don't see it.
Well, I see it. I don't know if it comes up for everybody else.
Yeah, I don't see your link either. Here, let's. I'll drop it. Here's the Imager link. You want to send me your Discord link or the link in Discord, and I'll just drop it.
So that's specifically the point stuff. That if you're interested in how the points are moving, but there's a.
All right, let me copy that. The code I don't know why it's not taking your chat. It's strange. You've been banned.
Yep.
Cool.
Many crazy ideas. But yeah, so if you have a look, like this is actually a very good example of talking about using inheritance and stuff, right? So I've got this concept of a point generator. What is a point generator? Well, it's an interface that generates points. And if you actually this might be a fun one to bring up because it actually shows specifically the topics we're covering.
Oh, sorry. The video got muted. Let me pull up this link. Just trying to get it up.
It's funny, like I just reposted this recently, but this code is like 2 years old. It's funny whenever you look back in your older code.
All right, which one do you want to open up?
Yeah, so if you open up the point generation folder, and then there's one just called point generator, and
point generator.cs. Yeah,
that's just the interface. Yeah, and so you'll see there that it's a very rudimentary interface, right? It's just the standard concept of this is a thing that knows how to generate points, and it's got no implementation except for the basic idea that here's an array of points, call generate, and then there's some specific settings, and you can ignore the generics, with the general idea being that generate points, regenerate points, and I can then, if you notice in that little GIF, it switches between using a sphere and using a circle, and it's sort of the points move, and it sort of ambulates the different points, and that's because I'm just swapping out the generator at runtime. And if you have a look at the two generators, if you go back a folder, you can look at the circle generator and the sphere generator, and they're just the same thing. It's just there's a particular algorithm that generates points along the circumference of a circle or a sphere. Right, and I just swapped them out.
So. Generate circle points. So you call generate circle points and that's in your
right there, yeah.
Public static generate. Oh, okay, wait, that's a setup method, right?
Yeah.
Okay, and
so
then
I have a static version, so you could say circle point generator dot generate points, or you could create an instance of it and then hot swap the instances based on the strategy.
And then you call this generate right here. So what's really happening is you're calling generate. You're overriding generate on that base class, and then generating the points right here.
Yeah.
Okay. And then if we go back to it was circle and what was the other one? Line.
There's circle, sphere, and a few others.
Oh,
I find circle and sphere are the two cooler ones, but the ones are like a points along line is another one, and there's a few others.
Got it. So here you just do generate sphere points, and I assume it just goes in 3D instead of 2D.
Pretty much.
Okay, nice.
So yeah, it's not like it's the most complicated code in the world, but it just generally gets the idea across that if people are wondering about this stuff we talked about, you can imagine having injected in, spawn cubes, and I'd pass in a point generator. It would create a load of points, and I would spawn the cubes along the points. I have not decided whether they're in a line, whether they're a circle behind me, whether they're a circle around my waist like a hula, whether they're a sphere of objects, whether I'm, whatever shape I want to make. I can just inject that as I go, right?
Yeah, you just swap out your generators and do all kinds without. Why didn't you just put a big giant switch statement in here?
I know, right?
Why generate based?
Who needs switches? You can just use if statements, right? Just if else the whole way down.
A bunch of if else statements. Hey, don't get. I did it before, right?
I think we all have, to be fair, at some point.
By the way, I was going to mention we should probably do a video on generics sometime.
Yeah, that's a very big topic.
Example with the point generator and having this generic one. I wonder, I'm sure this catches people off guard because before I got familiar with and really comfortable with generics, I'd see this and be like, okay, this is some advanced crap I don't understand. Right? Yeah. And while it was a long time ago, I can imagine a lot of people, it's very easy to get in and build games and never use generics. I think you could build and release a game, have it be successful, and never use generics and know the benefit and the time saving they could give you.
Yeah, I find there's almost like a chain of events, right? Like you start writing code, then you start writing object-oriented stuff, and then you start moving into generic stuff, and then you start using reflection, and then when you start using reflection, you start moving past reflection and start using things like writing your own custom compiler stuff, and then you start writing your own lowering rules, and it gets into this crazy category of like your code. You end up getting to the point that you're writing code that writes the code that writes your code. It's insane. So yeah, generics fall into that really weird category of you're kind of stepping away from the code at that stage.
Yeah. Yeah, and I think the chat in there at the end, generics are super easy once you grok them. That it's just imagine copying and pasting a bunch of different classes for each type, basically.
And the worst is when you start getting those weird mismatches, right? Like you start getting an issue because your covariance or contravariance is wrong, and you're like, what does this even mean? All of a sudden, it's giving me weird errors that I can't cast from like a list of dog to list of animal. Why? That makes perfect sense in my head, and it's like, yeah.
Drove me nuts at first. When I first ran into that problem, I was like, C# is broken. Like, how do I fix this? Is there a tool to fix this? Took a while to set in, yeah. So yeah, we'll have to do one about that sometime soon. Just dive into generics with some examples.
I think the simplest example is we could just do a really simple repository. Like that's basically would be a very good example for why you might want to use one.
Yeah, that's not a bad idea. Do like a repository to save off all kinds of different stuff, and then show the ways. Yeah, that'd be a good one.
Because I think I did an example for that a while ago. I think I did a save version where I saved out, and you could hot swap between player prefs or text file or binary file or XML or JSON or SQLite, and the idea was that you could just sort of use a generic contract for any entity type to any resource type.
Yeah. I like it. We'll have to do it soon. Okay. Well, I'm out of stuff.
Yeah, I don't
know if you got anything else.
No, I think I'm done as well.
These sound like good things to talk about again in the future. And again, I'll put the links down below. Don't forget to like, share, and subscribe and all that stuff. Only one person subscribed throughout this whole stream. That's terrible news. But thank you, Junkie McCrat. Hey, it's Junkrat. All right. Anyway, so don't forget to like, subscribe, share, and all that stuff. And fill out that survey if you get a chance. And then check out Jason's stuff. And hopefully by next week, he'll have a channel that you can go subscribe to as well.
Yeah, I kind of feel like 3 times in a row now I've said I will. So I think I kind of have to for the next one.
I'd say if you don't by next week, I should just try to pressure you into doing it live on the stream.
Physically go through the menus on stream. Yeah.
Good stuff. Well, it was great talking to you again, man. And thanks to everybody coming out here and listening to us chat and joining in. It's a lot of fun.
Don't forget to like as well before you go. Really appreciate it.
All right. Thanks, everybody. Goodbye.
Good luck.